So we are going to model our plate tectonics with snack tectonics. Before you start, a layer of newspaper is always great to help with cleanup. We're going to build our plate demonstrations on wax paper because that's nice for cleaning up too. Our magma is going to be this marshmallow fluff. It's really sticky but spreadable and can act like our magma. For our continental crust, we have graham crackers. They're a bit lighter, they have a lower density, and they're a bit thicker. For our oceanic crust, we're going to use fruit roll-ups. They're thinner and more dense and easier to push around. We'll need some butter knives for spreading our magma around, and we'll need some water as well. Here we're going to have converging plates with continental crust, represented by our graham crackers. We're going to give them a quick dip in the water, maybe to a count of 3. 1, 2, 3. And set them up here. Now, over hundreds of millions of years, as you push these plates together, you can see we get no subduction. Everything gets kind of pushed up, and we end up building some pretty high mountains. This would be like where the Indian continent meets the Asian continent, and we get the Himalayan mountains. They eventually get to a certain height and start falling down a little bit, but you can see we've built up over a long period of time some really great mountain ridges. Now we're going to look at a different kind of convergent boundary. We're going to look at what happens when we have an oceanic crust, an oceanic plate, and what happens when it collides with a continental plate. Okay, and when these come together, we're going to have subduction. That means one plate will slide under the other. Since the oceanic plate is denser, it will subduct under the continental plate, and we have them come together like that. You can see this doesn't happen smoothly. We get some ripples, and you'll see a very deep cleft where the plate goes underneath. We will also get some earthquakes happening because these will not happen smoothly. We can see some ripples happening here where our plates collide. Now we'll look at convergent boundaries with different oceanic plates. There's a layer of water over this. When we push our plates together, we will still get subduction. The more dense plate will subduct underneath, and we'll get a deep oceanic ridge forming where this happens. We can also see this is not going to go smoothly. We're going to get plates rubbing together, and we will see some earthquake action, so maybe some tsunamis. But also along here, we will eventually, after hundreds of millions of years, see some volcanic action where melted magma starts coming up through the crust again. Here we're going to try to show divergent plates with an oceanic crust. We have our magma underneath, and as the plates move apart, we can see how the crust thins, and we get little fissures forming where the new rock tends to come through and eventually cool and form new rock. And the farther we get away from where the split is, the older the rocks are. And that's one of the clues they had that this was going on in the Atlantic. We have one more divergent situation where our plates are moving apart. This would be on a continental plate where there is a split, and you end up getting like a rift valley forming. Now the crust is so thick that we end up getting fracturing and blocks of rocks, but you end up seeing this valley here being formed where the continents split. Here we have our transform fault. This is where one is sliding one way and one's sliding the other. They might not fit together particularly well, and so a lot of pressure builds up and a lot of force builds up and then suddenly lets go. And this is where we get sudden motion and some earthquakes as our plates slide along.